Welcome everyone. So today I will be taking another popular doubt, popular misconception. Here is a question. So I have named this as a two block system. Here we have got two blocks, 1 kg and 4 kg, kept on the smooth ground. The ground is smooth and there is friction between the blocks. And a force of 20 Newton is being applied on the lower block, that is 4 kg. So the question is find out acceleration of the blocks. So here the misconception is when students try to solve it, attempt it, they don't know whether the blocks will move together or whether the blocks will move separately. So do they have to find a common acceleration, a single value of acceleration with which both the blocks are moving together, or do they have to find out two values of acceleration, one for 1 kg and the other for 4 kg? They don't know this. So how do they try to solve? They use the logic that here the force being applied is 20 Newton and the maximum friction possible between the two blocks 1 kg and 4 kg, maximum value of friction, that is, so that they try to calculate. So if you calculate that, here you see the normal reaction on the 1 kg block, it is 10 Newton and the maximum value of friction force mu n. So 0.5 into 10, that is 5 Newton. So the maximum value of friction force is 5 Newton. Here the force which is trying to pull is 20 Newton. So they try to compare these two things and they tell since this force is greater than the maximum value of friction, so both the blocks will move separately. Here is a mistake. This is the misconception. The force here doesn't have any direct relationship between with the friction here. You can't compare it like this. Here maximum friction is 5. So you can't tell that a force of 5 Newton here or more than 5 Newton here moves them separately and a force of less than 5 Newton here makes them move together. That's not the logic. That's the misconception. So I have divided this video into three parts. First I will show you that the force here is greater than maximum friction. So here maximum friction is coming out to be 5 Newton. So I will take one example. Here the force is greater than 5 Newton. Still they are moving together. Then I will take another example where this force is greater than 5 Newton, the maximum value of friction, and they are moving separately. Right? So from that we can understand that how much force is required here to move them together or move them separately. It doesn't have any direct relationship with the friction force here. Right? Then the third part, in the third part of the video, I will tell you how do we find out that force up to which the blocks can move together, and if the force is applied more than that, then they move separately. So let's start. So first, let me give you the algorithm to solve such kind of question. So write down the 3 steps. How to solve such kind of question. Algorithm. First step, assume they are moving together. Assume they are moving together and find out the common acceleration and find the common acceleration. Second part, draw FBD of any of the block. Draw FBD of any one of the block and use Newton's law, form equation and find out friction acting. Find out friction acting, that I am denoting it as F. And then in third part, you also find maximum friction. You also find maximum value of static friction possible between the blocks and then perform this check. What check you should perform? Check if the friction what you have calculated in step 2 is less than the maximum value of static friction which you have calculated in step 3. If you find that this check, after performing this check, you find that this is true, that the value of friction what you got in step 2 is less than the maximum value of friction which you have got in step 3. If you are getting that is true, then our solution is correct. But let's say after performing this check, you find that no, the value of friction what you got in step 2, that's more, and the maximum value of static friction, that's less. If you find such a situation, that means this after performing this check you are finding it to be false, then our assumption and the steps of solving So this is incorrect. Then if you find false, then only you should go to the fourth step. Otherwise, there is no need to go to the fourth step. So the fourth step is assume they are moving separately. Assume the blocks are moving separately and solve. Assume that the blocks are moving separately. So solve them. Draw free body diagram, apply kinetic friction, and solve them. Hope you understood the algorithm. So all of you can note down the algorithm because I am going to erase it and I want to go to the next process, the next step. So let me solve it. The first step, I will assume they are moving together. Okay, so I assume that they are moving together with common acceleration A, and I will find A. How much is A? A is total force 20 by total mass 5. How much it is? It comes out to be 4. First step done. Second step, draw free body diagram of any one of the block. Let me draw free body diagram of 1 kg block. I am not showing all forces. Here there are 3 forces acting on this block. One is mg and the other is normal reaction. But just let's focus on x direction, horizontal direction. So the force acting on the 1 kg block is friction and its acceleration is a, which we have already found out it to be 4. So use this second step. Write equation, apply Newton's law, write equation. So F equal to ma for horizontal direction. That gives me friction equal to m into a. That is 4 Newton. Acha. Then go to the third step. So I have done the first step here. I have done the second step here. Now the third step. Find maximum value of static friction. What is maximum value of static friction? We know it to be mu n. So here mu is 0.5 and normal reaction is how much? Here normal reaction is, you see it is equal to mg, that is 10. So that is 5 Newton. Okay, now let's perform the check. So you see friction acting, which you are getting from second step, that's 4 Newton. Maximum value of friction, which you are getting from step 5, that is 5 Newton. What do you find? F less than Fs max? Yes. Yes. So instead of writing true or false, let's write it as yes or no. I think that's better. So yes, so our solution is correct. So they are moving together. So in this question, what is the acceleration with which they are moving? Answer is they are moving with 4 meter per second square. So what is the friction force acting? The friction force acting is 4 Newton. It is static friction acting. Maximum value of static friction 5 Newton. That's not acting here. That's not acting here. Remember, mu n is the maximum possible value of static friction which may act. It doesn't act always. Here, 4 Newton friction is required to move the blocks together. So 4 Newton friction only acts here towards right. Anyway, so my point was about the misconception. So here you see maximum value of friction is how much? 5 Newton. The force with which the blocks are being pulled is how much? 20 Newton. Isn't this force greater than the maximum value of friction? Yes. Still you see they are moving together. So the logic that if you apply a force more than maximum value of friction, then they will move separately. That's wrong. So here we have seen a case where the force acting is more than maximum value of friction. It's more than 5 Newton. Still they are moving together. Okay. Now I will go to another example. Let's change this value. Let's make it as 30 Newton and again solve this question. So 30 Newton and again solve this question. Let's find out the accelerations of the bodies and the friction force acting. So let me apply the 5 steps again for this data. Hope all of you remember the algorithm. First step, assume they are moving together and find out acceleration. Yes, they are moving together, force 30 Newton, total mass 5. This comes out to be 6 meter per second square. Okay, what is the second step? Second step, draw FBD of any one of the blocks and find out friction acting. So I am taking 1 kg block and drawing its free body diagram. So F, so this is moving with acceleration A. I have not shown mg and normal reaction because they are in vertical direction, they are not required. So net force equal to ma, m into a, that comes out to be 6 Newton. Okay, what is the third step? Third step is find maximum value of static friction and then perform the check. Achha, maximum value of static friction, that is mu n. and that comes out to be how much? 0.5 into 10, that is 5 Newton. Okay, then perform the check. How much maximum friction you are getting? 5. What is the value of friction which you got from second step? That's 6. What do you find? F less than equal to Fs max. Have you found that here? You see, this you have got as 6, this you have got as 5. So perform the check. Is is 6 less than equal to 5? The answer is no. The answer is no. That means they are not moving together. That means, so I had informed you that after you perform the check, if F less than Fs max, yes, so our solution is correct. You have to stop there. Is F less than Fs max? If the answer is no, that means they are not moving together, they are moving separately. So again, draw free body diagram assuming they are moving separately with acceleration a1, a2 and with a kinetic friction acting between them, and then solve. That's what we are going to do now. So now we have understood that blocks are moving separately. Blocks are moving separately. So let me draw their FBD. So for 1 kg block, the FBD will be here kinetic friction is acting, and that's the maximum value of friction. That's 5 Newton. This side mg, this side normal reaction, and it is moving with acceleration a1. So how much is a1? Total force in x direction by mass. That is 5 by 1. That is 5. Okay, now coming to the 4 kg block. So here is the 4 kg block. It is moving with acceleration a2. The forces acting are 30 Newton, the applied force. This side, kinetic friction. Kinetic friction is acting here. It is 5 Newton. And in the vertical direction, mg normal direction, they are acting. I am not showing them. So the acceleration will be net force towards right, that is 25 by mass, that is 4. So 25 by 4 meter per second square. So in this case, what is the answer? So the answer is both the blocks are moving separately. The 1 kg block moving with acceleration 5 meter per second square, and the 4 kg block moving with acceleration 25 by 4 meter per second square. So here what you see, the force is 30 Newton. What is the maximum value of friction here? The maximum value of friction here is 5 Newton. So you see, in this question, the applied force is greater than maximum friction. They are moving separately. But try to remember the first question which I solved at the beginning of this video. There also this applied force was 20 Newton, greater than maximum friction, but still they were moving together. That means this force in both the cases is greater than maximum friction, but in one case they are moving together and in the other case they are moving separately. So till now I have completed 2 parts of this video. How to solve this question and find out acceleration and friction acting. Now the third part is, okay, then on what principle we can know what is the maximum value of force up to which they will move together. कितना फोर्स यहाँ पे होने से जीरो से लेके कितना फोर्स तक दोनों साथ में जाएंगे और कितना फोर्स से ज्यादा होने पर दोनों अलग जाएंगे, वो कैसे पता चलेगा? अगर वो मैक्सिमम फ्रिक्शन के साथ डायरेक्टली रिलेटेड नहीं है तो फिर वो फोर्स कैसे निकालेंगे? So let's find out that. So I'm erasing this again. So now we are moving to the third part of the video. How to find out this force? How to find out this force up to which they are moving together. Okay. So let's analyze this question. This is 1 kg block. This is 4 kg block. Let's draw the free body diagram. So I am only showing the forces which are acting in horizontal direction. Okay? So on 1 kg block, friction is acting in this direction. On 4 kg block, applied force is acting in this direction, and friction is acting in this direction, isn't it? Now try to think about their acceleration. So the acceleration of 1 kg block, you see, it depends only on the applied friction. It depends only on the friction, and friction has a limit. So acceleration of 1 kg block has a limit. It has a limit. Now acceleration, let's say this block moves with acceleration a 4 kg. You see, acceleration of 4 kg block, it depends on 2 forces. the applied force and the friction. And this applied force can be anything. It doesn't have any limit. It depends on the desire of the person who is pulling it. So the acceleration of 4 kg block also doesn't have a limit. It can be anything. Depends on the desire of the person who is pulling it, isn't it? So acceleration of the 1 kg block here has a limit, whereas acceleration of the 4 kg block doesn't have a limit. Okay, now if they have to move together, if they have to move together, with what maximum acceleration they can move together? It's like asking, let's say 1 kg block is a cycle, a person driving with cycle, which has a speed limit of 20 meter per second. This is a crude example to understand. And let's say this 4 kg block is Shaktiman, who can travel with any speed, right? So that 1 kg block is, let's say, a cycle driver who has a limit. Maximum speed uska 20 meter per second ho sakta hai. Now this lower kg block, let's say, Shaktiman is there who can travel at any speed. Now tell me, what is the maximum speed up to which they can move together? The answer is जो इसका limit है. So can they move with 1 meter per second square together? Yes. Can they move with 2 meter per second square together? Yes. Can they move with 15 meter per second? 15 meter per second square? Yes. Can they move with 18 meter per second square? Yes. Can they move with 20 meter per second square? Yes. So sorry, I mentioned it as velocity. You can apply the same logic to velocity or acceleration, like that. So the acceleration and the velocity of a cycle has a limit, let's say, and the acceleration and the velocity of Shaktiman doesn't have a limit. So it's the same logic. So now, can both of them move together with 21 meter per second square? No, because this fellow has a limit. So the limit of this person is the final answer up to which they can move together, isn't it? Similarly, here also, the acceleration of this block has a limit and the acceleration of this block doesn't have a limit. So the maximum acceleration up to which they can move together means the maximum acceleration of this block. So maximum acceleration up to which blocks can move together. Blocks can move together means it is the maximum acceleration of 1 kg block. It is the maximum acceleration of 1 kg block, isn't it? What is the maximum acceleration of 1 kg block? It is the maximum friction on 1 kg block by its mass. How much is that? Maximum friction on that 1 kg block is mu n, mu into n by its mass, that is 1. So this comes out to be how much? 5 meter per second square. So the maximum acceleration with which both the blocks can move together is 5 meter per second square. Okay, at that time, which is the force pulling it? So when both the blocks are moving together with maximum possible acceleration 5 meter per second square, this force is m into a. 5 into total mass 1 plus 4, that is 5, that is 25 Newton. That means the maximum force up to which they can move together is 25 Newton. So if you apply a force, which force? Anything from 0 Newton to 25 Newton, then both the blocks can accelerate together. If you apply a force, which force? Anything higher than 25 Newton, 25.0001 Newton or 26 Newton or 28 Newton, 32 Newton, any force larger than 25 Newton, then they will move separately. So this is the concept. So this was the third part of the video. How do you know that maximum value of force up to which both the blocks move together? You see, that doesn't have any direct correlation. So there is a relation. It's not that there is no relation, but the way students compare, it's not like that. You see, this is 25 Newton, right? And the maximum value of friction is how much? 5 Newton. So whenever we want to find maximum value of force up to which they will move together, these are the steps. We should not directly jump to the conclusion that here maximum friction is 5 Newton. तो 5 से ज्यादा फोर्स होगा तो दोनों अलग चलेंगे, 5 से कम फोर्स होगा तो दोनों साथ में चलेंगे. वो गलत है, वो मिसकंसेप्शन है. Thank you. So if you like this video and you found it to be valuable, then please like our channel also, subscribe to my channel, share this channel amongst your friends, and encourage us by commenting in the section below. Thanks.